Welcome to this CipherVibe Cloud Security Guide. Today, we will make how to secure OC Cloud, step-by-step security guide for 2026 practical, prioritized, and connected to how real cloud environments are operated. Securing Oracle Cloud infrastructure is not one IAM policy, one network rule, or one CloudGuard toggle. It is an operating model that connects tenancy design, identity domains, compartments, groups, dynamic groups, policies, virtual cloud networks, security lists, network security groups, logging, CloudGuard, security zones, vault, object storage, vulnerability scanning, workload hardening, and incident response. This guide turns Oracle Cloud infrastructure security best practices, CloudGuard guidance, security zones, vulnerability scanning, object storage security recommendations, and logging guidance into a practical step-by-step hardening plan for 2026. The purpose is not to memorize a collection of service names. It is to build a mental model you can apply when accounts, teams, workloads, and threats change. We will define the core ideas, walk through a repeatable security workflow, examine mistakes that frequently create exposure, design useful safeguards, and finish with a practical hardening roadmap. Pause when you need to. Write concepts in your own words, record observations, and distinguish what the evidence proves from what you are merely assuming. That habit is more valuable than rushing through another tool demonstration. Start with 4 concepts that provide the vocabulary for how to secure OC Cloud, step-by-step security guide for 2026. First, the tenancy and compartment layer defines blast radius. Use compartments to separate platform services, security tooling, production, non-production, regulated data, shared networking, and experiments instead of placing everything in a flat root structure. Second, the identity layer decides who or what can act. Use identity domains, groups, dynamic groups, federation, MFA, short-lived access patterns, and least privilege policies instead of broad tenancy-level access. Third, the policy layer is the control plane contract. OCI policies determine which subjects can inspect, read, use, manage, or administer resources in a compartment, so scope statements carefully and review inherited access. Fourth, the network layer limits reachability. Design VCNs by trust boundary, use subnets deliberately, prefer NSGs for workload-specific rules, constrain route tables and gateways, and keep management and data services private where possible. Fifth, the telemetry layer preserves evidence. Use audit, logging, events, monitoring, notifications, and service connector hub to route control plane and workload evidence to protected destinations and security operations. Sixth, the response layer assumes something will eventually fail. Prepare playbooks for compromised users, exposed buckets, permissive policies, leaked API keys, public IP exposure, suspicious CloudGuard problems, key rotation, compartment isolation, and backup recovery. Do not study these as isolated definitions. Ask which asset or business service is involved, where the relevant trust boundary sits, which identity performs the action, and what reliable evidence would show that the control worked. Security reasoning is a chain. Source evidence supports an observation. The observation supports a conclusion. The conclusion informs a proportionate decision. The decision has an owner, an expected result, and a way to verify it. When any link is missing, say so. A professional explanation can include uncertainty without becoming vague. For example, a network record may prove that 2 addresses communicated, but it may not prove which human initiated the action or whether the content was malicious. Now turn the mental model into a repeatable workflow. First, create or review the OCI foundation first. Define tenancy ownership, identity domains, federated identity, compartment hierarchy, naming standards, tags, environments, shared networking, logging compartments, and security administration boundaries. Second, harden identity next. Require MFA for administrators, review local users, remove stale API keys and auth tokens, prefer groups over direct user access, separate break glass accounts, and use dynamic groups for instance and function permissions. Third, write least privilege policies. Scope access to compartments. Avoid broad manage all resources statements, separate inspect, read, use, and manage permissions, document policy intent, and review inheritance from the root compartment. Fourth, build the network baseline. Inventory VCNs, subnets, public IPs, internet gateways, NT gateways, service gateways, route tables, security lists, NSGs, load balancers, bastions, and private endpoint patterns. Fifth, enable managed posture and detection. Enable Cloud Guard for monitored compartments. Use detector and responder recipes deliberately. Create security zones for sensitive compartments and route problems to accountable owners. Sixth, protect data and keys. Secure object storage buckets. Use encryption and key rotation. Restrict public access. Configure vault and customer-managed keys for sensitive workloads. Protect backups and verify restore paths. Point 7. Practice response. Define severity levels. Preserve audit evidence. Disable or rotate compromised credentials. Quarantine workloads. Close expose network paths. Rotate vault keys or secrets. Isolate compartments or VCNs. Restore from tested backups and document verified closure. Before acting, define the objective, scope, owner, and success condition. Collect the smallest amount of trustworthy evidence needed to understand the situation. Preserve timestamps and sources so another person can follow your reasoning. Priorities should be explainable. Consider exposure, identity and privilege, sensitive data, business importance, exploit conditions, existing safeguards, reversibility, and confidence. A dramatic label should never replace that analysis. The workflow does not end when a command succeeds, a ticket closes, or a dashboard turns green. Verify the new state with fresh evidence. Check for recurrence and for side effects introduced by the change. This disciplined loop, observe, interpret, decide, act, verify, and learn appears in every cybersecurity specialty. Understanding failure modes will protect you from attractive but unreliable shortcuts. First, a flat compartment model hides ownership and makes access hard to reason about because development, production, shared services, security tools, and regulated data inherit inconsistent policies. Second, broad policy statements create large blast radius. Manage all resources in tenancy, wildcard permissions, and root-scoped administrative access can turn one account or API key into control of too much infrastructure. Third, local users, API signing keys, auth tokens, and customer secret keys can persist longer than expected. A leaked key in a repository, laptop, CI variable, or support ticket can bypass normal interactive login controls. Fourth, public exposure is often accidental. Public buckets, public load balancers, open security lists, permissive NSGs, unmanaged public IPs, exposed databases, and unrestricted bastion or SSH paths create avoidable entry points. Fifth, missing or mutable logs make response slow. If audit, logging, events, VCN flow logs, load balancer logs, database logs, Cloud Guard problems, and vulnerability findings are incomplete or poorly retained, responders cannot reconstruct what happened. Sixth, Cloud Guard can be enabled but ignored. Detector findings and responder actions need scope, ownership, severity rules, workflow routing, suppression discipline, and evidence that remediation worked. Point 7. Security zones are powerful but require design. Applying maximum security guardrails without planning can block required workflows, while leaving sensitive compartments outside zones allows unsafe configurations to drift back in. These mistakes often share one cause: confusing an available signal with a complete explanation. A tool can report a finding, a successful action, or a score while important scope, context, ownership, and verification remain missing. Also resist copying commands without understanding their inputs, outputs, permissions, and side effects. Run one controlled change at a time and record what happened. If an exercise does not behave as expected, that is useful evidence. Stop, inspect the environment, revise the hypothesis, and explain the difference. Good security work is not a performance of certainty, it is careful reasoning under imperfect information. Reliable security uses layers because no single control can prevent every failure. First, use an OCI landing zone pattern with compartments for platform, security, logging, networking, production, non-production, sandbox, and regulated workloads. Apply consistent tags, policies, budgets, and ownership. Second, adopt least privilege with identity domains, federated groups, MFA, reviewed local users, dynamic groups, narrowly scoped policies, credential hygiene, access reviews, and monitored break glass accounts. Third, use Cloud Guard for posture monitoring, activity detection, problem triage, and responder workflows. Tune detector and responder recipes so high-risk findings reach accountable teams quickly. Fourth, Use security zones for compartments that require preventive guardrails, especially sensitive data and regulated workloads. Understand that CloudGuard must be enabled before creating security zones. Fifth, centralize evidence with Audit, logging, events, monitoring, notifications, service connector hub, protected log groups, retention policy, and alerts on policy, identity, network, key, bucket, and logging changes. Sixth, protect data with object storage private defaults, public access review, encryption, vault, key rotation, customer-managed keys for sensitive systems, backup restore tests, and data access monitoring. Point 7. Harden workloads with vulnerability scanning, OS patching, image scanning where applicable, private subnets, NSGs, WF or load balancer controls, bastion patterns, database security features, infrastructure as code review, and deployment identity scoping. For each important risk, ask 5 questions. What makes the event less likely? What evidence would reveal it? Who can contain it? How will trustworthy operation be restored? Who owns the decision and accepts remaining risk? Least privilege applies to people, applications, devices, automation, data stores, and administrators. Access should be scoped, separated, monitored, reviewed, and removed when it is no longer needed. Every important control needs a test strategy. Include representative normal activity, negative cases, misuse, dependency failure, and rollback. A written policy is not evidence that a technical or operational control works. Finally, preserve the evidence trail from observation through decision, action, and verification. That history supports investigations, audits, lessons learned, and honest measurement. Turn this guide into a focused OCI security hardening plan. Start by inventorying tenancies, identity domains, compartments, policies, groups, dynamic groups, local users, API keys, auth tokens, public IPs, buckets, VCNs, subnets, route tables, gateways, log groups, and CloudGuard status. Then fix identity risk. Require administrator MFA, review federated groups and local users, remove stale API keys and auth tokens, reduce broad root compartment policies, separate emergency access, and document policy owners. Next, centralize evidence. Protect audit and logging destinations, configure events and notifications, route critical signals through Service Connector Hub, and alert on identity, policy, network, vault, bucket, and logging changes. After the evidence layer works, enable CloudGuard targets and recipes, triage high-risk problems, create security zones for sensitive compartments, and close public exposure in buckets, load balancers, databases, security lists, network security groups, and public IPs. Finally, protect secrets and data with vault, encryption decisions, key rotation, object storage controls, vulnerability scanning, backup restore tests, workload patching, and private access patterns. Measure progress with percentage of compartments covered by CloudGuard targets, number of broad tenancy-level policies, local users and API keys by age, public buckets, and public IP exposure count, critical CloudGuard problems by owner. Vulnerability scanning critical findings by compartment, backup restore success rate for critical OCI workloads. Each metric needs an owner, a reliable source, a review schedule, and a known limitation. The strongest OCI environments are secured by an operating rhythm, clean compartment design, least privilege, narrow policies, centralized evidence, CloudGuard monitoring, security zone guardrails, protected data, tested recovery, and rehearsed response. For chapter markers and primary Oracle links, open the description. For more evidence-based cybersecurity research, visit CipherVibe.com and subscribe to CipherVibe. Copyright 2026 CipherVibe. All rights reserved. This briefing is general education. Validate controls with authorized administrators in your own OCI environment.